Hi everybody and welcome to this video tutorial about how to program Quico control board for sliding gates. What we have here today is a Movie 230 volt sliding gate operator. Our control board can control all 230 volt sliding gate operators, and we will have a look more in detail. This control board here is QK CE 220 RL4 control board, digital control board with many modded functions to make an easy setup, a quick setup, together with maximum safety for the system. Today we will have a look together to how to make the major connections and the major software programming for the board. The major parts for the board are, of course, the display, the area of the push buttons, the terminal blocks, and the fuses holder. This is, as you can see, just a top cover that hold the replacement fuses in case there is something wrong with one of the fuses. We will now have a look to how to make major connections of the terminal block. We will first remove the fuses holder. The major connections are, of course, the motor itself, where number 13 and 15 are the phases, and number 14 is the neutral. When connecting the motor, remember that together with the two phases you need to connect the capacitor, and that the phases of the motor are normally distinguished by black and brown cables. Black and brown are the phases, and blue is the neutral. When doing the first connection, it is not important on which direction you connect the black and the brown, because you will adjust it later on during setup. So at this moment we have connected our motor already with the phases. Then in case of a sliding gate operator, of course, there is a limit switch system. The limit switch system is connected in connectors number 5, 6 and 8, where number 8 is the common, number 6 is the opening limit switch, and number 5 is the closing limit switch. So 5 closing, 6 opening, 8 common. What we need to connect to start the system is, of course, the mains. The mains gets connected to connectors number 19 and 20. For us to make a quicker process now during this video tutorial, we prepared a pre-connected terminal block. We are gonna connect it here. Then we can give power to the system, and the control board will turn on. You can see from the display. So let's see how to make the connections to the low voltage terminal block. We are gonna switch off the system first. Then we consider that we have terminal block number 1, 2, 3 and 4. That is for start push button, stop push button, external photocell and internal photocell. We will see in detail now during the video. We will see in detail how to make the connections. The control board has one common for normally open or normally closed contacts, and it is terminal block number 8. The common is number 8, then you have all the other contacts. We will now connect a start push button, in the case you want to wire a start push button, and we will see how the system works. Here we have a pre-wired push button that we can connect to the start signal of the control board. So we will remove the terminal block. we will connect one of the two cables of the start normally open push button to the terminal block number 1. Okay, we can plug the terminal block back. Then we need to connect the common. We remove the terminal block of connector number 8 that is pre-wired to the limit switch common, and together we are connecting the common of the start push button. So we connect both the common of the limit switch and the common of the start push button to the common terminal block of the control board, which is number 8. We'll connect to number 8. Here we are. Okay, so now we have our push button connected. The common was connected together with the common of the limit switch cables to terminal block number 8. We plug the terminal block back. Okay. We switch the control board on again. And we can test that the system works properly. You can see that if I press the push button, there is a go coming on there, which means that the system is getting the signal. We will now see how to connect a stop push button to the control board. The stop is a safety device, so it needs to be a normally closed contact. All safety devices like photocell or safety edge and the stop need to be normally closed contacts. What we have here is a pre-wired sample push button. They can be of different kinds. It's just an example to show you the connection in the video. So the terminal block number 2 is the contact for the stop. We are gonna wire it to terminal block number 2. Then the other cable has to be connected to the terminal block of common, which is together with the common of the limit switch connection. So we are gonna remove limit switch cable, and we are gonna put the two cables together. And wire them properly to the terminal block. Okay, we can check now if the push button is working by checking if the display shows ST. Internal photocell is the photocell that is inside the property and is commonly working during opening only. And external photocell is the photocell that is outside the property and is commonly working during closing only. There are different setups for the photocell to change their function a little bit from the software of the control board, but the standard working is as I said earlier. Have a look to how to make the connection. We will open our photocells first. So we open the front cover of the photocell. Each photocell set is made by a receiver and a transmitter. The receiver is marked as RX on the top cover, and the transmitter is marked as TX. So we are gonna remove the top cover and get access to the PCB of the photocell. We will open the top cover of the transmitter as well. And now proceed to all the connections. As you can see here, there are 4 terminal blocks, 4 connectors on the receiver and 2 connectors on the transmitter. The 2 connectors on the transmitter are for power supply only. The other 2 on the receiver are with the contact. So let's first have a look to how to connect the power supply to the photocell from the control board. Before connecting the photocells to power supply, please consider that the control board is supplying 24 volt DC to the system. Both receiver and transmitter PCBs are equipped with a jumper that can select the voltage that you are gonna supply. You must make sure that as per factory standard, the jumpers on the transmitter and the receiver are settled on 24 volt DC, as you can see here and also on the receiver. We will now connect minus to a blue cable. Okay, and plus to a brown cable. Okay, so we have minus connected to a blue cable, plus to a brown cable. You can use whatever cables colors you prefer. This is just to explain how to make the connection. The same we will do on the transmitter. So again, we will connect minus to the blue cable. And plus to a brown cable. So we now have connected the terminal blocks of the power supply of the photocell to blue cable for the minus and the brown cable for the plus. We just now need to prepare the cables for the contact of the photocell. So to terminal block number 3 of the photocell receiver, we connect a cable that is for the contact. And to connector number 4, we connect the other cable of the contact. Okay, now we have our photocells wired, both receiver and transmitter. We will now see how to connect to the control board. First, we will connect the contact, which is from connectors number 3 and 4 of the receiver. We will now connect to our external photocell connector, which is connector number 3. So connector number 3 is for external photocell contact. We then need to connect the other cable of the contact to the common, which is number 8. We have now connected the connectors of the contact. One is connected to number 3 of the control board. The other one is connected to number 8 of the control board, which is the common. We now need to connect the power supply to both the receiver and the transmitter of the photocell. We did wire the blue cable to the minus on both receiver and transmitter. So the blue cables of power supply from receiver and transmitter need to be connected together to terminal block number 10 of the control board. So we did connect the blue cables coming from power supply of the photocell, the minus. We connect them to connector number 10 of the control board. Now we just need to connect the plus from photocell, which was the brown cable from both the transmitter and the receiver. To connector number 8. Connector number 8 is both common and plus for the power supply. So connector number 8 makes simultaneously the common for contacts and the plus for power supply. Okay, we have now connected our photocells to the control board. Minus from both the receiver and the transmitter was connected to connector number 10 of the control board. Plus from both the receiver and the transmitter was connected through the brown cable to the connector number 8. And the two blue cables from the normally closed contact of the photocell that is placed on the receiver were connected to connector number 3 and connector number 8. It is worth mentioning that connector number 3 is for external photocell, the photocell that works in closing only. Connector number 4 is to be connected for internal photocell, the photocell that works in opening only. For example, if you want this photocell to work in opening only, you need to place and connect instead to number 3 to number 4. We will now check if the photocells work fine. We power the system up. We can see that the relays of the photocells are clicking, so at least the photocell is powered. Now you need to align the photocells on the gate until the TC disappears. You can see from here, if I align the photocells, then the photocells are working fine. If you disalign the photocells or pass an object in front of the photocell, you will see that the photocell is showing TC on the display. TC corresponds to the error report on the control board that is related to external photocell. This is to say that when there is an object interfering with the photocell, you will see on the display TC. This is to understand what's wrong with the system because the display is always showing what is happening with the system. We will now see how to connect a Quico flashing lamp to the control board. We need to remove the top cover of the flashing lamp. Okay, the two terminal blocks of the flashing lamp needs to be connected to terminal block number 11 and 12 of the control board. 11 and 12 of the control board. We will now put a couple of cables. We will wire two cables to the terminal block of the flashing lamp. Okay, we will then wire the second cable. Okay. We will then wire the other side of the two cables from flashing lamp to connectors number 11 and connector number 12 of the control board. Okay, so now our flashing lamp is connected. It is a 24 volt output for the flashing lamp, so no high voltage needed. We can now check if the connections were done properly by switching on the system and giving a start signal to the system. The flashing lamp is flashing. It will flash in high speed during opening and slow speed during closing. There are 4 push buttons on the board: A, B, C and D. Buttons number A and B are to go up and down in the selection of the function. Buttons number C and D are to change the specific function to another parameter. You can see here we change, for example, from function number A1, which is the standard working time. We go to A1. If we want to change the working time, we need to change it with the C and D buttons. For example, we are now reducing working time to 20 seconds only. So A and B to go up and down in the function, and C and D to change the specific function setting. To go out from the functions menu, you can wait some time until 2 dashes appear on the display, or you can simply press A or B buttons until 2 dashes appear on the display. That's it. We will now see how to program quick or remote control. We have here a QK MO4 remote control on the control board. As you can see, when you press the button, there is any button, there is a red dot coming on the display of the control board. This means that the control board is detecting a radio signal, but it is not recognizing it because the remote control still has to be stored inside the control board receiver memory. What we have to do by means of A and B buttons of the control board is to go on R1 parameter. R1 is the parameter of the standard opening. So the standard opening can be controlled by remote control. You press one button of the remote. While the red dot is on, you keep the button of the remote pressed and then you press C button. You will see a number coming on the display. Every time you press the button, you will see the number related to that button. For example, we will now press button 2 of the remote to program it together. You will see the display showing number 2. So we press number 1 and 2. The remote control is now programmed. You can go out on the parameter R0 to see how many buttons were stored on the receiver so far. So now we store 2 buttons. The display is showing the number of buttons that were stored till this moment. We can have other functions on the receiver. For example, R2 if you want to save stop button. For example, we want to program button number 3 of the remote to make stop function on the system. So we press button number 3, we press the C button on the control board, and the stop push button will be stored. There is function number 3 that is to have a specific button for pedestrian opening. For example, we want pedestrian opening to be controlled by button 4. Then we go to parameter R4, press C button, and the button number 4 will now control the pedestrian opening of the gate. It is worth mentioning that with Quico Digital Control Board you can have different functions on the same remote. So, for example, standard opening, pedestrian opening, stop, and fast closure. If we want to cancel a remote, a single remote, we need to go to R0, wait for the number of the remote that you want to cancel. For example, you want to cancel remote number 4, and while the 4 is being displayed, keep C button of the control board pressed. Then the previous button number 4 has been cancelled. Let's have a look again. Let's say we want to cancel button number remote control. We want to cancel remote control number 3. We go to parameter R0. We wait for number 3 to appear, and then we keep C button on the control board pressed until the display gets off. We now have just 2 remotes programmed. To cancel them, we can make a total erase of all codes by function R5. You need to go to function R5 while the display is showing no. Keep C button pressed until the display stays steady. By doing that, all receiver codes were cancelled. We will now program R1 standard opening button again, so to show how to make standard working time setup for the gate. We will now see how to program the working time of the system. To program the working time, you need to go to parameter A1 that per standard is set at 30 seconds and set the number of seconds that you would like to set. Let's assume that your gate takes 30 seconds to open. Okay, because this control board has a slowdown function, we recommend to set A1, which is a standard working time, at, for example, 27 seconds, and A2, which is a slowdown working time, at 10 seconds. This is because during the normal opening, the gate will start, work for 27 seconds, and then work another, let's say 10 seconds until it reaches the limit switch. It's not important if it reaches the limit switch earlier than the 10 seconds. That's why we recommend to leave slow down for at least 10 seconds. What is important is that there is enough time during slowdown to reach the limit switch. We will now, to make an example, a quick example, we will now set A1 standard working time for say 10 seconds, okay, and we will set A2 slowdown for another 10. We will have a test. We will hear the motor working at normal speed for 10 seconds and then slow down until reaching the limit switch. When the opening limit switch is pressed, FA appears on the display, while when the closing limit switch is pressed, FC appears on the display. So once again, if your gate takes, let's say, 30 seconds to open, you will set 27 seconds standard opening, parameter A1, and you will leave 10 seconds to parameter A2. What will happen is exactly this. It will work for, let's say, 27 seconds. Then we'll start the slowdown and look for the limit switch. Once you have settled the standard working time and slowdown working time, basically you've done everything to get your system working properly. You can go and make more fine-tuning in the functions. We will have a look now to the major functions. For example, A3 is startup time. So it is the time from 0.1 seconds to 1.5 seconds that the control board takes to give maximum power to the motor. So if you want soft start, you need to set A3 parameter to 1.5. The motor will start soft and reach the maximum power in 1.5 seconds. Per standard, A3 parameter is settled at 0.1 seconds. Then we have A5 parameter that per standard is settled at 7. The minimum is 1, the maximum is 10. This is the standard force during standard speed. So let's say the force, the power of the motor is settled at 70%. 70% is a good average for almost all systems to work fine. A6 is power during slowdown. Minimum is 1, maximum is 10. Let's say that during slowdown the motor has 80% of the power. 8 is a good average to let almost all systems work fine. A7 parameter is obstacle sensing during standard speed. You can set it dependently on how much pressure you want the gate to give before reversing when it touches an obstacle. So you can set it from very sensitive to less sensitive. Per standard it is disabled. You can enable it by setting the sensitivity. So A8 is the obstacle sensing during slowdown. A9 is motor brake function. This function is very useful for reducing inertia effect on some gates. It is enabled by standard. You can increase it or decrease it depending on the necessity. Then there are other parameters like F0 is the time for automatic closing, F1 is the time for pedestrian opening, F3 is pre-blinking, if you want the flashing lamp to blink some seconds before the gate starts. F5 is to set step-by-step function or not step-by-step. F6 is community mode. Community mode on F6 doesn't get start signals during opening or pause. So when the gate is opening or when the gate is in pause, you cannot stop it or interrupt it if community mode is enabled. F8 is related to the photocells logic. Normally you can leave the one that is standard. If you want to change, referring to the user manual, you can change the photocell logic. L0 is if you want to connect an electric lock by means of the connector. There is an optional PCB to be connected to the board to control an electric lock. You can from L1 set, from L0 set if the electric lock is connected or not. L1 is cold winter function. It is very useful for cold countries to avoid both the motor and the control board to freeze under very cold temperatures. You can set it from 0 to 10 and you can refer to the user manual for more details. L2 is a recovery loop function, which is useful in some cases when the gate starts from the middle and not from the beginning. It will go in slow down speed until it finds the first limit switch. This is again to avoid inertia. T1 parameter is to enable photocell test if you want it. T2 is normally activated by factory and it is doing thermal protection test. If one of the motors or the motor is in thermal protection, the control board will detect it and show it on the display. R0, R1, 2, 3, 4, 5 are radio functions like we saw before. Then you have all the E parameters that are related to terminal block connectors number 1, 2, 3, 4, 5, 6 and 7. By means of E1, 2, 3, 4, 5, 6 and 7, you can set how you want each terminal block connector to work. For example, E1 parameter, per standard it is settled to give a start signal, but you can also set it to open only or close only. So you can set it to open only, close only, or by standard it will open and close. You can also disable it via software. Pay attention because all the connectors can be disabled via software, but you don't need anything connected to them to disable via software. If the control board detects something connected to them, you cannot disable via software. So again, E1 now we disable. Let's put it as it is per standard. So it is in go. E2 is the stop push button. You can disable or enable it. E3 is external photocell. E3 and E4 are for external and internal photocell. E5 is setting for the limit switch. You can set if you have a normally closed limit switch or normally open. E6 is for the opening limit switch. E7 is for the pedestrian, so that you can give a pedestrian input, or you can give an open only or a close only input, or you can disable. For example, if you want your board to have open only and close only inputs, you can use E1 as open only and E7 as close only. In this way you can have two different buttons. One will control the opening of the system, the other one will control the closing of the system. We will now see the error report. because as per the user manual, the control board during standby shows if there are some errors. For example, I will now remove the limit switches connection. You will see the board will detect an error, IH. IH, if you check in the display report table of the user manual, IH is related to an error detected to closing and opening limit switch. This is to say that every time that you connect a normally closed contact to the control board and there is something wrong with the normally closed contact, the display will show. For example, I'm gonna now make a bridge to the stop push button. Now the stop push button is disabled by software. We can also check it from here. We go to E2, it is disabled, it is set to no. We go out from programming. We kind of simulate the stop push button by doing a bridge, okay? Now we are simulating that the contact has been connected. If we remove it, the ST will appear to show that there is a problem with the push button or the push button of the stop is pressed. If you want to disable this contact again, you need to go to E2, you need to go to E2 and disable it. You cannot disable a contact if there is something connected to it. You can only disable if there is nothing connected. There is something worth mentioning related to the direction of the motor. When you first start the system, the motor will need to work in opening. For example, we switch off the system, we switch on the system again, we start the system. If the motor turns in other direction, so it turns in closing, what you need to do is switch off the system, reverse motor phases, so reverse what is connected to connector number 15 with what is connected to connector number 13, and try again. After that, you need also to replace opening limit switch with closing limit switch and swap it upside down. So after swapping motor cables and the two limit switch cables, you will start again the system. If the system starts in opening, then all the connections of the motor and the limit switch are proper and you can go ahead with following functions. So we saw major functions of the board and major connections. It is worth mentioning also that the board has a connector for electric clock and a connector for a smart module that allow the board to have some domotic, some smart house functions. There is an optional PCB that can be connected there. This item on the left is the radio receiver, which is normally wired to the standard antenna cable, but it can also be wired to an external antenna cable. The control board is equipped with standard fuses, and for the low voltage it is equipped with self-resetting fuses, so there is no need to replace the fuse in case there is a short circuit in the low voltage. And that's it. Hope you like our new digital control board, and let's keep in touch for the next video.